So let's talk about another great reaction, and this is actually one of those things I find pretty interesting, and that is the use of organometallic complexes to make carboxylic acids. So we can apply this to both Grignard reagents as well as organolithium complexes, but basically what we need is a carbanion. So we need something that looks like that, and we can accomplish this just things like MgBr, which is the Grignards, or we can accomplish this with organolithium complex. In either case, what we're going to do is we're going to take this carbanion and we're going to react it with CO2. We're going to draw CO2 in a very important way. So what will happen is, if we look at the negative and the positive, we've got a negative source here. We have a very good nucleophile. And we have a carbon here in a very, very, very positive oxidation state, in this case +4. So what will happen is the carbanion will attack the carbon, knock our lone pairs down, or knock our bond down, and we will end up with carboxylic ion. Now we're going to follow this up here with an acid workup, and this will give us the carboxylic acid. So what's the utility of this? Well, if we can generate any type of organometallic Grignard or organolithium and bubble CO2 through, we can immediately produce the carboxylic acid at any point we want to. So the challenge here is just going to be getting that organometallic reagent on the part of the carbon or the part of the molecule that we want to. But we can do primary carboxylic acid, secondary, and tertiary. Another cool thing is that we can also do this with things like benzene. So if this happens to be Br, which we could get by taking benzene and reacting it with Br2 over an iron catalyst, we can also create the organometallic Grignard of the benzene and directly produce the benzoic acid. So this is a useful tool here for putting a carboxylic acid wherever we want to in a molecule, as long as we can get a halogen, either chlorine or bromine, to the positions where we want that carboxylic acid group to be attached.